Alright, so before I actually begun my lesson, Casey had to take a pre-assessment, and she will possibly take this assessment again after we go through the lesson. So I kind of put it in the video, but it cut out somehow. My name is Ishella Craft. Today I'll be teaching students about motion and stability, forces of interaction, and we'll be using tug of war. And I'm teaching 3rd grade. This is a science lesson, and today I'll be teaching Casey. All right, so I will start off my lesson by asking, what do you think we're about to learn today, Casey?
Forces in motion?
Good job. And the reason why she said we'll be learning about forces in motion is because I actually have what we'll be doing today on my board in my classroom, which is right here. All right, so now I'll tell you to turn and look here, and we're about to watch a 3-minute video. We will not look at the whole 3 minutes. It's just to refresh your mind, because this is your first time actually hearing about it, but your 2nd grade teacher possibly covered it in the past.
In motion.
Wow. I'm okay.
How does an avalanche occur? What sets things in motion? What causes motion, and what stops it? Forces. A push, a stretch, a pitch, the attraction of a magnet, a touch, all these are forces. A force is a push or attraction exercised by one object upon another.
Did you know what a force was before watching this video?
No.
Okay.
As the force of the wind on the blades of a windmill, the attraction between 2 magnets, an ox pulling a wagon, or your foot kicking a ball. A force would not exist by itself because it is an interaction. What this means is that it depends on the relationship between various objects.
Ah! All the things that surround us exert forces on each other, and this is constantly happening.
Some forces act in tiny things, such as those joining the water molecules to form a drop.
And other forces act on humongous things, such as those governing the motion of the planets.
Forces affect the shape and motion of all things. They can trigger the movement of an object, speed it up, change its trajectory, stop it, or just keep it still. Forces can do that through contact, when objects touch each other, but they can also do it at a distance, such as in magnetism, electricity, or the force that keeps us glued to the ground. Do you know which force that is?
Do you know what force that is?
Gravity.
Can you?
Gravity.
Good job. Good job.
Every time something moves or changes its shape, there are forces at work. And when nothing changes, forces are at work too, offsetting or overriding each other.
And what forces would cause an avalanche?
Why is he worried about that?
Oh, okay.
All right, so now we'll be heading outside for an experiment which is involved in tug of war with a rope. So I want you to grab your science journal, the sheet of paper that says tug of war, and your rope and your pencil. All right, and now we head outside. All right, part 2 of this is now me and my students are outside, and we are using this rope, which is their example rope. On the first rope, I'll be asking, is this rope moving?
No,
And why isn't it moving?
because it's not moving.
How can you make the rope move?
I don't know.
Okay, Casey, I need you to get serious. How will you make the rope move? What can you do to make the rope move?
Pulling it.
Okay, that's one way. So I want you to record all those ideas down in your science journal right now on how you will make the rope move. Right, cool. You a tall character. Right. To one page there. All right, right. Alright, so once you finish writing, you can look up at me and let me know at least 2 of the ways that you can make that rope move.
Okay.
You ready? Mm-hmm. Yes, ma'am.
Yes, ma'am.
How will you make the rope move? No. How will you make the rope move?
By pulling it.
Mm-hmm. You can be louder than that. Can you be loud? It's okay.
By pulling it from one end to another.
Alright. So now we'll move on to actual rope, and me and my students will be coming up with a scenario on how we can show a force between the rope and what would happen if one side is actually stronger than the other. Alright. So you get on one end, I get on one end of the rope. Which end do you want to be on? Okay, so you want to be on that end, so now move this. Alright. So, we can come in a little bit so we can wrap it around, tad bit. Like kind of see us, you know. Come in. Alright. Oh, you're kind of tall. Alright. You ready to pull?
How much time?
Oh, alright. So, yeah. Alright. That's fine. You can put it down. Alright. So, what do you think caused me to pull it so strong toward my end? So, who had the most force? Yeah. And why is that? Because you're larger. Alright. So, okay. Even though that rope isn't moving anymore, it still has a force up on it. Okay? Because that force is keeping it down, which is gravity. The ground is pushing the rope up, and the forces on both ends of the rope are the same because there is no one pulling on the rope. So, for example, I'm about to show you how the rope is being unbalanced right now because I'm pulling on one end of it. See, one person is moving. But when there's nobody touching it, it's just laying there flat. It's balanced, alright? You understand? Yes. Alright. So, I also want you to know that, we did all this. Alright. So if there was more than one student, of course, I will be able to show this in 3 different ways. So we talked about 3 different ways that we would try to give an example of how the rope is balanced and unbalanced. So the balanced force would be this. The unbalanced force would be me pulling her over to my side. Another unbalanced force that me and her discussed were or ways that we could try to show that it was balanced or unbalanced was she said that we could do 2 girls and 2 boys on one side, all boys on one side and 2 girls, just or give a side which has more girls because the boys just might possibly be stronger. So it was a lot of ways that we talked about that. Now so do you understand the difference between the unbalanced and the balanced force? Alright, so louder. Alright, so give me an example of a balanced force. What would be a balanced force? Anything right now besides the roads. And why would the truck be one?
Because it's
Okay, it's not moving and it's on all 4. Alright, and give me an example of an unbalanced force. I know there's not going to be one outside right now, but you can think of one. I can give you one, but you can't. I'll give you about 5 or 6. The motorcycle. Alright, so she said that the motorcycle would be an unbalanced force if it wasn't on a kickstand, which is correct because a motorcycle cannot hold up on its own without a kickstand to lean on. So that is correct. Alright, so yep. So once we head back in the classroom, I'll just give you the next set of instructions. So what you're going to do right now is you're going to grab your science notebook, your pencil, and your rope, and we'll head back inside. Alright, so now that we're back inside, I now have to tell Casey that I want her to give me the definition between a force, a balanced force, and an unbalanced force, and I want her to write that in her science notebook. Then after you do that, I'll tell her to go pick up this sheet of paper, which is her journal write, and she'll be writing about one object in the room that's not moving, and she'll draw arrows and stuff to illustrate the forces that's acting on the object. And here's her line so she can actually explain it, but the line should explain it as well. So this is actually going to replace where I asked them to tell a story and write a story describing unbalanced and balanced forces, because actually with that force, she'll be actually letting me know that she understands balanced forces or unbalanced forces, or even a force that's just being acted upon, and even with it just sitting there. So, that was okay. Alright, you done? You finished? Yeah. Alright, so let me hear what's a force, unbalanced and unbalanced force.
unbalanced force.
Mm-hmm.
It's a force that causes objects to change in motion.
Alright, and what is a balanced force?
When 2 equal forces act in opposite directions.
Alright, and what's force?
A push or pull.
Alright, so now what I want you to do is quietly get up. I'm sorry. Quietly get up and find one object in the room, in the classroom, that is not moving. And I want you to use arrows to describe. You know how the arrows were in the video that I showed you? When you, okay, you remember?
Yes.
If not, we can go back and watch it at the closing of this lesson. But what you'll do is you'll use those arrows to describe how it's not moving, even though a force is acting upon it, even though it's not moving. So you're gonna explain the force, explain what you're writing about, and then go from there.
Oh.
Yeah, and then you
I got it.
do it for real. It can't be moving. The object can't be moving. she's still working on that. This is the quiz that we'll be closing off with to see if she actually understands the difference between unbalanced and balanced forces. It's actually showing something which we did today, which was with pulling the rope. All right. So we're going to say she talked about a bottle. All right. She talked about a bottle. She drew the bottle and used arrows to basically show that gravity was actually holding the bottle down, and also the fact that it's sitting on the dresser. So it's on a balanced force with nothing being pushed or pulled upon it as well. So let me actually just show you guys while I can. It's just sitting here. So that's what she used. All right, it's fine. Good thing we're not outside doing this experiment while you're drinking. All right. So now we'll correct. Thanks for letting me know that. All right. So now we'll close this lesson off by taking the quiz. And the quiz, like I explained to her, it's 1, 2, 3, 4, 5, 6, 7. It's 7 questions. This is pretty much your SAT. Yeah. So once you finish that, our lesson is pretty much over. Yes, ma'am. Yes. Okay. With the arrows. This is definitely left. This is right. This is not my time to let you know if you got it correct or not. I'll be grading it. Then after that. Sounds adorable. Cool. You finished?
Oh my god, I went to university.
All right. Pulling the forces are working. Opposite forces. Good job. Not equal. Good job. The forces. Pulling to the. Correct. The weaker force is pulling to the right. Motion is to the left. No. Why is the motion to the left and not the right? Motion is to the. Why you say left?
Oh. Because I thought about it was 2 people pulling. But really they pulling. But the lady, she's standing there. So it looked more like they pulling instead of. Makes sense?
But you said the motion, if they're pulling instead of her, then why did you say the left? This is the right. You get what I'm saying?
Oh.
Alright. So, like I expected, I had this student only had 1 question wrong. We'll just show it, but she only had 1 question wrong. Instead of the motion being pulled to the right, she said the left. But so we just need to go back and talk about motion and the pulling the forces. But pretty much she understood the lesson and understood the concept of balanced and unbalanced forces. So that's it.